Hi, my name is Sai Akshara Challa, and this is my Lab 1, Charge Tapes. The purpose of this lab is to explore the electron transfer between surfaces using charge-clear tapes and estimate the number of excess electrons or charge on the tape, and to also use GlowScript to simulate real-life interactions. Some key concepts used in this lab are Newton's second law, gravitational force near the Earth's surface, and Coulomb's law. Newton's second law states that the net force of an object is equal to the change in momentum over change in time. The second equation shows the gravitational force near the Earth's surface pointing in the negative y direction, where m is the mass of an object, g is the acceleration due to gravity. Force that a charged object exerts on another charged object is equal to the product between the Coulomb constant k and the quotient between the two charges and the square of the distance between the charges multiplied by the unit vector r hat. R points in the direction of the force to the point of exertion. Remember that the magnitude of the electron force does not have a unit vector r hat and takes the absolute value of the charges. The value of k sub e is a Coulomb constant defined in image 4, the last image at the bottom. Some results of the lab is that the charged clear tapes had a net positive charge, and the charge on the tape is positive 1.87 times 10 to the negative 8 coulombs, and there was an electron deficiency by 1.17 times 10 to the 11. Some assumptions made in the lab is that air resistance ignored, and the procedure for creating a charge is the same for both tapes. And I also assume that the point charge is located at the center of the tape to ensure that the U tapes can be coded as a single point charge in GlowScript and to ensure that the math is easier to do. These are the experimental procedures I used to conduct my lab. For this lab, I used 2 uncharged pieces of clear tape. These 2 tapes acted as my system A and system B, and I created U tapes, and then I charged the tapes, and then I tested for charge, observed the interactions, and then I suspended one U tape on objects of equal height, and I placed another U tape below the suspended one and observed its motion, and then I measured that distance. And then I also observed interactions between the tapes and charged objects like a plastic pen. Feel free to pause this video and read my procedure in more details. Here is a model diagram of the experiment. When I followed my procedures, some observations that I noticed were that the 2 U-tapes repelled each other, and the tape was attracted to neutral objects like my hand, and the U-tape was attracted to negatively charged pen. The pen was negatively charged because I rubbed it on cloth, and the electron were stripped from the cloth and onto the pen, and the tape A repelled against tape B. Here's a free body diagram modeling my experiment. The tape B acted as the suspended U-tape, which is the system, and tape A was the held U-tape, which acted as the surroundings, and also the Earth was also the surroundings. As you can see, there are arrows going up and down. The up arrow from force B is the electron force from the held U-tape onto the suspended U-tape, and the bottom arrow represents the force of gravity, and these forces are repelling each other. The net force on the suspended U-tape is 0 because it is at equilibrium. Now on to experimental data and calculations. These are my data values. The tape length was 0.2 meters. The tape width was 0.019 meters. The atom length was 1 times 10 to the negative 9 meters. Gravitational acceleration is 9.8 meters per second squared. The tape mass per meter was 0.2 grams per meter, 1 gram per meter converted, and the floating distance r was 0.04 meters. Using the data from the previous slide, I was able to calculate for the gravitational force, the charge on the tape, the deficit electrons, and the number of atoms in the tape, also the electron to atom ratio using the formula stated here. I used GlowScript to further model my data. The first initial lines show the constants in my experiment, and in line 17 I used the function from lab 0, plugged into the force of gravity formula and the magnitude for the E-force, and used Coulomb's law to solve for Q. I also divided Q to get the magnitude of the electron charge and to find the electron deficiency. I also divided the area of the tape by atoms to get the number of atoms in the tape. I also divided the number of electrons by the number of atoms to get the atom ratio, and the model shows the B tape suspended over the A tape, and the purple arrow shows the force of gravity, and the blue arrow shows the force of the electrons. These results were very similar to the shows I got from my calculator, and this is because the GlowScript was a lot more accurate, and the way that these two calculated the values are similar. I saw that there is an electron deficiency because the tape is positively charged, and the net force is 0. Some possible sources of error were inaccurate measurements of the tape length and width, imprecise measurements of the separate distance, misalignment held of the U tape and the suspended tape, and not handling the tape properly, and rounding. To answer the what if questions, the positive charge U tape would become negatively charged and the electron field would point towards the tape instead of away from it, but the overall observations would remain similar because the tapes would still have opposite charges. And why is it important to handle the charged tapes as little as possible? This is to eliminate error because the more contact the tape has, the more its charges alters, and the U tape will probably gain electrons from your hand, which will decrease its positive charge on the U tape.